Hello, this is the last video of this week. So, we are going to consider an example. Suppose that x, as in the first question of this slide, let x be the annual income of a randomly chosen person. And suppose that you know the answer and you know the mean and the standard deviation of x. Suppose that the true mean is $50,000 and its standard deviation is $10,000. But you know these two numbers, but you don't know the details about the distribution. Typically, income distribution is not normal because there are super rich people, so it's usually there are extremely large outliers and the distribution is positively skewed. And then, now in this situation, you know the answer, but there is an economist who wants to study the distribution of X. So he surveys 100 people and calculate his own average income. X bar is the average annual income of those 100 survey participants. And what we are going to do here is, I'm not interested in the economist's analysis result, but I will predict the error, estimation error by this survey. We can predict how much this economist can be wrong. For example, I'm going to calculate the economist underestimates the average income by more than $3,000. So you know the answer. The true mean, the true average income is $50,000. But this economist may underestimate that in his average. What is the probability that the difference is more than $3,000? Let's do this. We can do it. First, set up the question. We would like to calculate the probability of underestimation by more than $3,000, which means the economist's result is less than $47,000, right? The truth is 50,000, and even without reading the economist's result, we can predict the probability of underestimation. And to do that now, in order to calculate this probability, the first step we have to do is to calculate the mean and the standard deviation of the average, the economist's average. The economist's average, X bar, has the same mean as the original mean. So the expectation of the average will be $50,000, which is the original mean, and the average is standard deviation. The standard deviation of the average equals to the original standard deviation divided by the square root of the sample size, which is $1,000. So the original standard deviation was 10,000, but you have to divide it by square root of 100, which is just 1,000. So you know the mean and the standard deviation of the average from 100 people. And then, because you know these two guys, you know the distribution of the average using the center limit theorem. So, center limit theorem implies that the average of 100 people follows a normal distribution with these two parameters, and the parameters are already calculated. Already we know them. So 50,000 and 1,000 are the parameters for the normal distribution. So that means we know everything. We know X bar follows normal distribution with 50,000, 1,000. Then, now back to this probability. In order to calculate this probability, we have to standardize the probability. So X bar is a non-standard normal distribution. So standardize. Subtract the mean, divide by the standard deviation, and do the same thing for the other side. We have done this exercise in the previous slide, previous chapter. And plug in the numbers. We know these guys. So 50,000 and 1,000. And if you calculate them, it's minus 3. So the probability that the economist's result is smaller than 47,000 equals to the probability that a standard normal distribution smaller than minus 3. And this is a cumulative probability. So we have this probability in the table. So from the standard normal distribution table, or if you use Microsoft Excel or a program or calculator, you should be able to find it. The answer is 0.135%, only 0.1%. So if you survey 100 people, the probability of underestimation more than $3,000 is only 0.1%. So as you see, we have we used only two uh, two results, two numbers, the mean, the original mean, and the original standard deviation. If you know the original mean, original standard deviation, and the sample size, which is usually known, and only from these three numbers, you can predict the accuracy of the estimation. And this is what we are going to do in the next chapter. So when you estimate something by yourself, you can predict the probability of your error using this way. So this is how we utilize the central limit theorem in statistics. And I'm going to continue next week. And I guess next week, Tuesday's lectures would be pretty short. I have delivered all the results. It's too simple. It's super important, but it's too simple. So this chapter is supposed to be short, but this is very important. It makes your life much easier. Okay, thank you for watching. Have a nice weekend. Stay safe, and please do the homework. See you later. Bye. By the way, I sent out an email email about a survey about this course, how I'm doing in this course. So please give me some feedbacks. I'm really curious. I have seen no student coming to my office hours yet. Uh, please, please let me know what I need to do more or what you want from me. I will try to improve. Thank you.